we have the vector u equals 3, 4, v equals 1, 4. And the class was asked to, everybody in the class was asked to sketch these two vectors, which they did quite well. It looks like this. And then to project the v vector onto the u vector. Okay, that means we go from the tip of the v vector and we move perpendicular to the line of the u vector until we hit that line. Now I say perpendicular to the line of the u vector because the v vector could well be much longer and it wouldn't hit the u vector at a perpendicular, but it'll hit the line of the u vector at a perpendicular. The v vector could even be back here, and to bring it to a perpendicular we have to go this way to the line of the u vector, so we'd have to extend the line of the u vector backwards. Well, in this case, it turns out that the v vector, if we go from the tip, we can go directly perpendicular to the u vector. We don't have to extend the line of the u vector in order to do this. And we get this right triangle here because, of course, we're doing this at a perpendicular to the u vector. That makes this a right angle, doesn't it? Okay, so we have a right angle here. Then I asked people to estimate the length of this side and estimate this angle. Well, we got estimates. Kind of a middle-of-the-road estimate based on the estimates people provided in class was that this side was 4. So I got 4 with a question mark here to see how close our estimate might have been. We're actually going to be able to compute this in just a minute, very easily. Okay? And theta was estimated to be 30 degrees. Now we can actually calculate this, and we can actually calculate the angle. So what we do first is we're going to make a unit vector in the direction of the u vector. Okay, so unit vector in the direction of the u vector, well, we divide the u vector by its magnitude. Its magnitude is 5. Dividing it, we get 0.6, 0.8. Very straightforward. Okay. Then we want a vector of length 4 in the direction of this unit vector, because the vector from here to here has to be in the direction of u. The unit vector is in the direction of u. If we multiply that unit vector by 4, we're going to get a vector of length 4, and it's still going to be in the direction of the u vector. So we multiply our unit vector, which has length 1, by 4. That's going to give us a vector of length 4. And it's going to be in the same direction as the unit vector, and then clearly the same direction as the vector u. So we get the vector 2.4, 3.2. Now the picture's getting a little bit cluttered, but I'm going to clutter it a little more. I'm not going to indicate the unit vector. It'd be a short little vector down here. But I am going to indicate in orange the vector 2.4, 2.4, yeah, it's going to get messed up, 3.2. The more I try to make that 4 look good, the worse it looks. Okay, so that's going to be this vector here. Now, if we take the dot product of the unit vector with the vector v, we get 3.8. Okay? And that is actually going to be the correct length of this side. So it's really 3.8, and we really should, if we want to really get this vector right, multiply 3.8 by 0.6, Now how do we know that this is going to give us, that taking the dot product of v with a unit vector in the direction of u gives us the length of this projection? It goes back to the fact that the dot product is equal to the magnitude of this vector times the magnitude of this vector times the cosine of theta. If we dot v with a unit vector, then what we get is the magnitude of V times the cosine of this angle, which is this side of the triangle. So that's why this works. From this, we can also calculate the angle. Now, this isn't a completely accurate calculation, but the length of this side of our triangle is the magnitude of our V vector, and that's pretty close to well, it is the square root of 17, which is pretty close to 4.1. The length of this side, if you believe what I said down here, is 3.8, and that's equal to the magnitude of V times the cosine of theta. So that the cosine of theta is equal to 3.8 divided by the magnitude of V, but the magnitude of V is the square root of 17. So that this angle is the inverse cosine of 3.8 over the square root of 17, and that turns out to be pretty close to 23 degrees. Now you want to digest this a little bit, and the fact is that you might be a little bit rusty on your trigonometry, so you might want to review your right angle trigonometry and relate it to this example.